And now, the first real presenter is coming up. It's Mike North. He's a digital nomad. He works everywhere, I can tell you. I have observed this in the last few days. It's awesome. And he's going to tell you something about the bridging over the gap between native and web for mobile application.
All right. Good morning, everybody. So my name is Mike. This is the second time I've been to Jazoon. I'm so happy to be back. This is a fantastic conference. You guys have it you have it good because not everyone puts so much thought and planning into throwing great events like these. So this morning I'm going to be talking about, in line with our topic, write once, run everywhere. How do you write web-based code and tap into native functionality? And I arrived at this topic in thinking about, what do I bring to this conversation that maybe not everybody has in this room? And in my case, I'm a polyglot. I've spent a lot of time building applications in different languages. I've written desktop apps in Java and mobile apps using Objective-C and Swift, and spent a lot of time in the JavaScript ecosystem trying to, build rich clients in this quirky application platform we have called the browser. And so I've had experience across all three of these ecosystems. And oftentimes when we're building mobile apps, right, this is where the users are going. More and more we can see that mobile users are eclipsing desktop users. So 2 years ago, we could see that both traffic and daily active users for mobile started to continue its already increased growth, and it's now the primary platform for, reaching customers in a lot of businesses. But the challenge is when you write a single code base and you're tapping into it because maybe you already know JavaScript. Maybe you have a bunch of JavaScript developers that, can already get up and running quickly. We want to make sure that we don't give up a lot of the power that these devices ship with. So I have an obligatory reference here. Sorry, guys. But today we're going to make mobile great again. And the way we're going to make mobile great again, and you're going to hear a lot of talks that dive into each of these areas, is we're going to talk about some of these tools that let you write once and run everywhere. And they fall into two categories. Some of these present a web view where you're using CSS and HTML, and you're creating kind of a full screen, browser that is taking care of much of your application's functionality. Others end up converting your browser-like code into something else, into something, closer to native. So what we're going to do today is we're going to pick an example from each idea, and we're going to build something that will illustrate how you can tie JavaScript code and native code together. And this is not to be overlooked, because no matter what you're doing, it's likely that you're going to want to tap into a lot of this native functionality. More and more, you're getting lots of sensors, you're getting the ability to tap into more information like address books and haptic sensors, and get better indications of location, right? Better than we have in a web SDK. And I don't want you guys to think of it as a black box. And typically, this is kind of the mental model, where you say, okay, I'm wrapping some JavaScript in Cordova, or I'm wrapping JavaScript using Ionic, and only when things go wrong, only when you need to debug something, do you hurriedly go and try to figure out, how does this Swift thing work, and how is it communicating with my app? You need to know what you're shipping, right? And until you can wrap your head around this, you're kind of setting yourself up for an unpleasant call at 3 a.m. or a quick, redeploy of an app because something breaks in this area that not everyone has a lot of experience in. So we're going to build two examples, and this is going to be a very focused talk. We're going to talk about just the bridge. And our case study is going to be a calendar API. And I just plucked these from the respective documentation on each site, but you can see that Apple has something called EventKit, and then Android has the Android Calendar API. They both they behave completely differently. They, in some cases, give access to totally different information, but we want to be able to create a universal facade on top of these so that the nativeness doesn't bleed into our application logic, right? You don't want a bunch of if Android, do this, else do that, because that's going to add to the existing challenge of building your product. We're going to start with Cordova. And the way Cordova works under the hood is you have some HTML, some CSS, and some JavaScript, and then over the Cordova bridge, you're talking to some native code, and that could be Java or Objective-C or C# if you're using Windows Phone. And really, you can think of the bridge as being Ajax. You can think of it as being Ajax. And it has changed a little bit between different versions, but you'll start to understand as we go through these examples, it's just like talking to an API. It's talking to some other foreign, process that is going to asynchronously return data back to you. And we should probably understand why we might choose Cordova, what it's good at. If you're used to programming for the web, you're excited about progressive web apps, you look at PouchDB and you say, hey, it'd be really nice to be able to sync, when a user comes back online, to sync their view of the world with our database and get everyone lined up again effortlessly. So anyone here used D3.js before? A couple people. So D3.js is a visualization framework that is probably 10 times more popular than any native graphing framework, or probably all of them combined. And so there are a lot of examples there, and for something like a dashboard, this would be a great tool to reach for. Essentially, you're embedding web content, and this is the example that has a full screen web view. And because it's been around for a while, there's a big plugin ecosystem. So if you can think of a sensor or an API you want to interact with, there probably is something out there that is close to meeting your needs. So let's look at the finished product so you guys know where we're going today. What we're aiming to build is a mobile app that very simply lets you click a button and get some information back. And the interesting part here is this is going to represent invoking native code from JavaScript, and then the native code transmitting data back into your JavaScript app, right? And so you see here that we've got Jazoon registered in iOS. We're going to see that it's registered in Android when we look at the Android view. And this is as simple as it gets because I leave it to someone else to dig into what you could actually do with this, but this is connecting two worlds, right? This lets you as a developer get access to whatever's in the iPhone 7, even if other technologies haven't implemented something for you yet. So let's get started. The way you start a Cordova project is you use Cordova CLI or something that is doing a similar job for you. And you're going to just name the app. You're going to pick a Java package, and it's going to create a project for you. And this isn't doing anything clever like installing dependencies. It's just creating a folder structure for you. And I want you to focus on 3 folders here. We've got platforms, plugins, and www. Platforms is where Cordova is going to take care of generating an iOS project for you with Xcode that you could open up and develop using conventional iOS tools. Similarly, you'll get an Android project in there. Plugins are where you get these little encapsulated modules that insulate your application from the device-specific complexity. And finally, www, that is the web content that will actually be embedded in Cordova. So this button that we saw in the finished example, that is going to be implemented in index.html. So the way you add a platform is you just say Cordova platform add iOS, and we're going to do the same thing for Android. This can take a while the first time you do it because it's building a lot of native stuff initially. And then we're going to create a folder, and we're going to build the shell of a Cordova plugin. So it's going to be a package.json file, which we're creating right now. You're going to see a plugin.xml file, and then we're going to create 3 pieces of our bridge in JavaScript, Objective-C, and Java, right? So we have the client side, the JavaScript side, and then the native side. And so you can see that we're kind of setting ourselves up for that folder structure there. There are some Yeoman generators that let you kind of start with a preset shell, but it is not all that complicated, and you can probably just end up creating it yourself. So if we look at this plugin.xml, this is not an area I want anyone to get hung up on, but the important thing is you can think of it as having the name, the description of your plugin, and then on a per platform basis, some configuration, and then like the entry point for your native source code. So we're going to create 2 files here, and for the Objective-C portion, and then we're going to create this Java file, calendarmanager.java. And we're not going to actually interact with the calendar, but I just wanted to have kind of a use case in mind. So now we actually have all of the pieces assembled, but we have to start implementing it. And we're going to begin with the Objective-C side. So essentially we have a plugin that's pointing to native stuff that's not there yet, and we'll start filling it in. So if none of you have written C before, that's fine. I'll explain what's going on here. We're first going to make sure that this header file is included only once. And we're going to define what's called an interface. And this is just sort of the structure of this class without the implementation. And you can see that we're extending from the Cordova plugin base class, and then we're going to stub out a method called addEvent, and that's going to take a single argument, which is a cdv invoked URL command. And if we go back to sort of the Ajax analogy, this is like your request. It's going to say, on this module, this command was invoked, and here are the arguments. Just like you might see that, if you're writing some Node.js code, we received a GET request at this path, and here are the parameters that were passed along. If we switch over to the implementation here, we're going to take care of our includes, and then we're going to define, we're going to use the @implementation syntax here, which is an Objective-C thing, and you could do the same thing in Swift. And then we're going to implement this addEvent method for real. So it returns nothing, it takes in this invoked URL command, and then we're going to wrap things up. And this is really all we have to do. It's one method. And the pieces that have to fit together here are we're going to initialize something that represents how we're going to respond to the JavaScript side of things. We're going to pluck off arguments that came in, so we get whatever JavaScript sent us. We're going to make a check to see if it looks reasonable. And if everything looks good, we'll return success. If things don't look good, we will return something that will be treated in JavaScript as an exception. This would be like returning a 500 or something, like a 500 status code. And finally, we have to actually initiate the process of sending that response back. So we're building this object, and then we're going to say, go and finish things up and execute all of this. So what would each of these look like in terms of code? Well, first we're going to create a pointer, just a reference to the result we're going to return. We're going to grab the first thing off of this arguments object. It's just an array, right? It should look very familiar to JavaScript, where we have arguments when we invoke a function. And we're going to get the 0th thing in that array. And then we're going to build a result that just adds some text that lets us see for sure this is coming from iOS. So we'll just append to that string, which is like the event name that we're going to create here. And we'll just say it was registered in iOS. And then we're going to do our little check, make sure that if the event name is null or empty, we end up returning something that looks like an exception. Otherwise, we will return something that looks successful. And you can see we're now for real creating the plugin result. We'll use special constants that indicate, success or error states. And the message is a string, and it's going to be that string something something registered in iOS. And then this is the equivalent if you wish to raise an error. And then finally, we're going to want to actually resolve this. We're going to use this global command delegate to transmit this result back across the bridge to our client. So this is it. This is all you have to do for a very basic kind of add something and echo it back Cordova plugin. Only a couple lines of code, only one class to implement, not too bad. If we look at the equivalent in Java, it's going to look pretty similar. So we'll say in Java you have to say this class is part of a package. We'll create the class. It extends from the base Cordova plugin class. We'll add all of the stuff that we need to import in order to make this work. And the one method that's important to implement here is called execute. And this is where you see a lot of flexibility in Cordova. And essentially, anything that you're asking Calendar Manager to do will just come across as a string, as this action, right? And so we're going to say that if it equals add event, we're going to hand off control to another method that we're going to implement. And then otherwise, if we return false, that kind of indicates that we don't know how to respond to this, right? So think of this as like a case switch, and then in default, maybe you handle this case where you got something unexpected. And finally, we'll implement this last little method here, add event, takes in a string, takes in this, the callback context, which is like our request object, and we'll do our same check, and we will return success if everything looks good, and we will return an error state if it doesn't look good. And it's not so important that you guys understand the particulars of what's going on, but I just want you to see it's a rather simple thing to reason your way through. It is very akin to AJAX or RPC if you guys have used remote procedure calls. So this is it. At 24 lines or 28 lines, we've got the Android piece of our Cordova bridge built. The last step, and we're going to go back to JavaScript, so breathe easy, guys. We're going to implement this universal JavaScript facade that we can use in our consuming app to talk to the native code. We'll begin by creating a closure that is immediately invoked. We're going to get a flexible reference on the Cordova global, and because there have been different versions and there are different ways to use Cordova, we kind of cover all of the bases here. We're going to create a new type and add an empty options object to the prototype or to the instance. And then there's our add event method coming up with the event name and 2 callbacks, one for success, one for fail. And this is all piped through Cordova's exec method. Everything kind of goes through exec and is transmitted, over the wire to the native code. The last thing is to make sure everything's initialized properly once Cordova starts up. So has anyone used jQuery ready before or document unload? So Cordova has its own events that it will emit when the whole, the bridge and all the hardware is fired up and ready to go. So this will make sure that we have access to Calendar Manager globally. So now we're actually done. So this is probably less than 100 lines of code total, and we have covered our bases in iOS, Android, and JavaScript. The next step is to link the plugin. And if anyone's developed like an NPM module or a Bower module, there's this link concept where you create a symlink within your application that points to the source code of your library. And this allows you to develop a library easily in the context of a basic application, right? You make sure that all the life cycles line up and everything's initialized properly. It's a nice way of avoiding all the copying and syncing up manually. So all you do is you use Cordova plugin add and then a local path. The -- link is what creates the symlink. Otherwise, it will just copy everything over, make a deep copy of the project, and then we're done. And you can see that a lot is happening behind the scenes, and you have a lot of lifecycle hooks that you can deal with if you have configuration files that need to be populated on a per project basis. This is basically telling you it found nothing in any of these hooks, but I just want you guys to be aware there's a lot of customization opportunity. So how do we use this plugin? what we'll need to do is go into our index.html, right? This is the visible portion of our app. We're going to modify the content security policy because I'm about to do something a little bit hacky in order to keep the example super basic. We'll remove some boilerplate, add a click listener here to a button, and then we're going to implement a global function to handle clicks on this button. Inside this method, we're just going to log, and then we're going to use the calendar manager that is available on the window object and pass it the name of an event, 2 callbacks. If things look successful, we'll alert, so we see data that came from native popping up in our UI. And if things don't look good, we'll just dump stuff to the console so we can debug easily. So now we're ready to build it and to run it. After you make sure you have Android Home set properly so it can find your SDK, and it's just Cordova build. It will go through the process of compiling both your Android Java app and your Objective-C or Swift iOS app, and then you can just say Cordova run iOS, and it will fire up a simulator here that you can interact with. Click, and you can see that data is coming from native, bubbling back up into JavaScript land, and then we're rendering it. So we've kind of completed the cycle here. If we look at something similar in Android, we're going to just open up this Android project that was created for us, pick a device to emulate, fire it up. By the way, make sure you don't have devices plugged into your machine as you're doing this, because what it will attempt to do if it sees a connection to like a development provision device, it'll try to deploy it to that hardware, and you need all sorts of certificates set up for that. So we can see that Android's taking its time firing up, and it's going to inject the app into the OS. We can click the button and we'll see the Android native code is bubbling up in our JavaScript. So we're done. This is it. It seems like a lot, but I walked through every single line that you need to worry about, short of showing you the package JSON that was created for us through the wizard. But this is start to finish, creating a Cordova plugin. So the takeaways I want you guys to remember is that the strength here is Cordova plugins allow you to contain all of the complexity and the specifics having to do with native SDKs in your plugins. You want those to be islands of complexity that you can deal with on their own, rather than having everything bleed together in an app with all of the complexity of your products. You only have one class to implement, regardless of whether you're talking to Objective-C or Swift or Java, just one class. And it's a callback style control flow, right? We pass in a success callback, an error callback, everything works. A point to remember, although it kind of depends whether this is a pro or a con, there's not much structure, and you could see that we just have sort of this exec method when we implemented our Java, and we were just looking for the string, and that's like a method that was invoked. That gives you a lot of flexibility, but it also doesn't give you much structure. So if you decide to build a bunch of plugins or modules that are fairly complex, make sure that you establish your own conventions and stick to them. And finally, plugins end up being pinned to the window object, and so they are available as globals in your browser-based code. Everyone following? Pretty much? All right, so this is great. Cordova's been around for a while. And we've covered our bases when it talks to embedded web view style hybrid apps. But let's talk about something that's a little bit newer and has a different mental model behind it. So who here has heard of React Native? Sweet. Yes. Very, very exciting stuff. Starting to become extremely popular, and we'll see why. We'll see why. Not necessarily better than Cordova. Different sort of best use cases in each of these. So let's look at what we're building, and I've tried to align the examples here as close to the starter app that's generated for free as possible, just so that I can show you, there's no magic happening here. We're literally showing you every command that's run. So this is the app that we're going to build, and when you click the small piece of text, you're going to see a notification. In Android land, when you click the smaller piece of text, you'll see an Android notification. We're going to build basically the same thing, but it's going to look substantially different. And one of the reasons that it looks a little bit different is the mental model behind React Native. And we don't really have JavaScript code running at runtime, because what's happening is you're using React, you're building on top of React, which is just a way of declaratively implementing things instead of imperatively implementing them. And if you're building React for the web, you're using React DOM to create your own custom components. Here, we're using React Native to create native mobile views. But everything's transformed at build time, and so the bridge is really, it's a more complex adapter because there's greater tight coupling here. React Native is doing something very different when it builds things for iOS versus Android, because it's converting things into something that's specific for iOS, specific for Android. Whereas Cordova just has sort of two loosely coupled pieces that talk to each other over a connection. So why might you use React Native? What are the strongest use cases? Well, of course, like many of the things you're going to hear about today, you get to write JavaScript. You get to tap into the rich JavaScript ecosystem. If you want Moment.js to handle dates, you can use that. You know, you really, the sky's the limit there. React is very popular, especially if you're dealing with contractors, consultants, and you want to have a big pool of people that can understand your code base. A lot of people are professionally using React. You end up with native views, and it's possible to get Cordova performing nearly as good as native or as good as native. But it does require a little bit of expertise to get there. There are things that people do for desktop browsers that just break when it comes to mobile. And it's no worse when you're dealing with mobile web, right? I'm sure you guys have used mobile websites that just take forever to load or they're not responsive. You don't want your mobile app to be like that. And what it adds that is, I think, better than building a pure native app is they put a lot of thought into how a developer is going to use this technology. So like a web developer, where they'll write some code and then hit save, and then their view will refresh within like less than a second, you know, using modern tools. That's very different than writing some Swift code, recompiling, sending it into your simulator, or potentially restarting the simulator, and then, you know, you see your splash screen and you have to kind of go and it's a very kind of old school way of building things where you in order to see a change, you have a lot more time to wait and a lot longer of a loop to go through. Finally, it's really easy to get started. They give you a working app that is easy to customize from the first moment. So let's get started. React Native has its own CLI. You just say React Native init, and then the name of your project. It's going to bring in some stuff from NPM and give you an indication as to how you will proceed. So we're going to run this command here, which is React Native run iOS. And we will see that it will launch the iOS simulator for you. You need to have Xcode and your command line tools installed. It's building things for the first time. This second window is interesting here. It's actually starting up a little web server whose purpose is to continuously, every time code changes, rebuild the native stuff and then load it into the device. And so you can see when we hit a hotkey, you end up with some nice developer tools here. They give you things like live reload and hot module loading. And interestingly, you even have an inspector. If you guys have used inspect element in Chrome before, even though these are native views, you can see that we have something that looks like a box model here, right? With margin and padding. It really does a good job of letting you keep some of these web tools that keep web developers so productive. If you look at the code that was built for us, we've got an Android project, an iOS project, our dependencies, and then an entry point for each Android and iOS. What I prefer to do here is to build kind of a base class and have very thin component subclasses for Android and iOS. I don't think that the split typically happens where it's like a completely different thing, Android and iOS. I think that since things are often shared, I want to kind of refactor it immediately. I'm not going to bother doing it, but it would just be, so these are essentially copies of each other right now. And they're giving you flexibility, but I find that often it's robs you of the chance to share as much as possible between the two platforms. If we look into the iOS project, we can see that it has actually built you something you can launch in Objective-C. And if we look at what's in there, it's just basically delegating control to React Native. There's really not much in this app, right? So if we look at the Android equivalent, again, get your environment variables set up properly, Android home, pointing to your SDK, and then you'll run React Native, run Android. It'll fire everything up. And we'll see sort of the starter Android app. Worth noting, you already have to have your Android emulator running. It does not launch it for you for some reason. But you can see here, Android has asked for the latest React Native code, and this has responded by transmitting it. So let's go through a similar process here, like we did with Cordova. We'll begin with Objective-C. So you'll end up creating calendar manager.h, calendar manager.m, and when we're building this iOS side of things, it's going to look a lot like Cordova. And you'll see that things look a little bit different when we get over to Android, but it is reasonably simple here. So we'll make sure that it's in the right place. And we're going to define our interface. And in this case, we're going to extend from the React Bridge module, base class that is being built here. So we're going to build an interface on top of an interface. And we don't actually have to implement or stub out any methods here because of how React Native picks up on our native code. If we look at the implementation file here, it's going to be even simpler than Cordova. So we're going to include our necessary headers. We're going to implement Calendar Manager, and then we're going to use what's called a precompiler macro. And I'll show you what that is, although I just think it's interesting, not critical to know exactly how this works. But we're just going to say RCT export module. You see RTC in a bunch of places, that just means React. And what that's going to do is have React Native pick up on the existence of this thing and make it available as an ES6 module in your React Native JavaScript code. It automatically happens. What's happening under the hood here, if we click on this, if you've ever written C or C++ code, this precompiler macro, you can think of it as a dynamic find replace that happens before the code is built. So it's just taking in JS name here, and you can see here it's implementing a method for you. Looks a little bit nicer, and if Facebook ever decided to change this method, they could just change the way the macro works, and your app would not break. So the second thing we're going to do is we're going to export a method, right? Because before all we did was expose this module. The first thing we're going to take in is the event name, and this is going to be Jazoon 2016. We're going to take in a second argument just so I can show you we can deal with multiple arguments easily here. It's an NS dictionary, so if you're a JavaScript developer, this is like an object, and if you're a Java developer, this is a hash map or a map. It's your basic key value data structure. And then the last argument here is a response sender block, just a fancy abstraction around a callback. So you can invoke this callback, and that will bubble back up to JavaScript, and in your React Native JavaScript code, that'll end up being what's called. So we will implement this. We'll just log something, and then we're going to pass a string back through the callback just to illustrate that everything works and complete the loop here. Now, what I like about this is it looks a lot more like this is Objective-C talking to more Objective-C code, where you're sort of invoking a method here, as opposed to preparing this response object like we did in Cordova and then transmitting it. That's a little more abstract. It doesn't feel as natural as just saying, here's callback, and I'm going to pass in an array with 2 items in this array. That's easier to reason about, easier to read. So now all we need to do is wire this up to the JavaScript. So everything, all of your React, your native modules are tagged onto this native module's ES6 module. And so here this is just an ES6 destructured assignment. It's basically native modules dot calendar manager. We're just plucking that off so that we can refer to it by itself. We're going to blow away, so we'll first add a click listener here, which will invoke the add event method on this and pass in some metadata. So this is our NS dictionary, our second argument. And then finally, we'll use an arrow function for the callback here and alert something. And now we're going to rip out some of the example stuff and replace it with something that responds to an event. So we'll just add an onPress listener here, which will invoke the handle click method. So if you're used to writing JavaScript and HTML, this is pretty approachable. That's all you need. That's it. And so let's go back here for a minute. So this has in fact completed the loop, right? But this isn't the most modern way to structure this, right? So when I see callbacks, I think like early Node.js code, where you end up with, they call it the pyramid of doom, where you've got callback, 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 and then you have to be responsible for bubbling all of the errors up. Promises are the answer to that, right? Promises are a great modern way of managing asynchrony. And React Native has a great way of sort of promisifying these native methods that you write. So all we have to do is we have to replace this last argument, which was our callback, with a pair of arguments, one for resolve, one for reject, and you simply invoke these, and React Native will detect that this looks like something that should be made into a promise, and instead of callback here, we're going to end up saying resolve, and that's the only change we have to make. On the client side, we're just going to change this to .then. We'll use destructured assignment again here, which is just plucking the first 2 items off of whatever comes in as that first argument. We'll show something a little bit more interesting on the screen. Oops, sorry. And it still works exactly the same. Except now it is a more natural thing to exist in JavaScript, right? We write promises nowadays far more often than callbacks. The last piece here, before I don't make you guys look at any more live coding, is to implement the Java side of things. Now this is where things get a little bit more complicated, and I don't know the particular reasoning behind the way this was designed, but we have to build 3 pieces here. We have to build first a package, which is a collection of modules, right? A package is just lists of JavaScript and native modules and view managers, logically grouped together. And then we'll build our calendar manager module, which will have this add event method on it. So unlike all of the examples we've been looking at, here we're going to be jumping between a couple files. So first we're going to create our Jazoon React package. And that is going to, once we implement all of the abstract methods that we need to fill in, we will see that it's basically returning 3 lists. We've got create native modules, we've got create JS modules, and then we've got create view managers. So it's just a collection of these 3 flavors of things returned as lists. And these 2 we're not worried about. We're just going to create a native module that we'll fill in just a moment. What we need to do next is go into sort of the root of our application and say this Jazoon package is something that we want to include in our app. And we just add to this get packages method this Jazoon React package. That's it. Now all of that will get sucked into our app and made available in JavaScript for us to use. So finally, we're going to implement our calendar manager, and we're just going to call it calendar manager module. And it's going to extend the typical base class for these modules. Every example I've seen extends from this base class. But it has all of the functionality necessary to detect stuff that you've implemented and make JavaScript functions out of them. So this is the only abstract method that you must implement, Calendar Manager, and this is what's going to make sure that this thing has the proper name in the native module's JavaScript object. Sorry, guys. All right, good. So you don't get to see me typing, but this is the add event method here. Takes in a string event name, takes in something called a readable map, and then this promise is a promise in Java land, right? That at the end we can resolve this promise with the result, and that will kind of complete the loop and send us back into JavaScript land. One thing that's interesting here is when we were working with the React Native iOS stuff, we got this NS dictionary, which is the typical key value stored when you're key value data structure that you use when you are working in Swift or Objective-C. But in this case, we're using something that's a little bit non-standard. And I'll have to dig into it a little more, but from what I can see, there are some issues around serialization that required a little bit of extra bookkeeping here. So you have to use readable map and writable array, which up here you can see, these are things that are part of the React Bridge Java package there. So there is a little bit of a limitation here where you have to buy into Facebook's Java data structures, which there are ways of converting things back and forth, but it's not as nice as exposing the usual way of dealing with data. And here we're just creating an array and we're pushing two things into it just like we did in Objective-C. So the last thing that we're going to do is go back to our package, add this native module, the Calendar Manager module, to the package. We're going to basically return a list with one element in it. So this package is just one native module, and that native module has one method on it. That's all we need. So a lot more involved here, but pretty easy to reason your way through once you understand that it's just a more complex way of organizing things. It's not really code complexity. So when we run it, we can click it, and we can see hello or OK from Android land. So this proves that we've got our loop completed, and we're having Java code invoked by JavaScript and data from Java being returned into the JavaScript runtime. So we kind of went over a lot here. Here are the takeaways that I want you guys to remember. React Native is different from Cordova in that you're building native views. And for that reason, it has some more flexibility when you're trying to customize native UI elements. If you're mixing a lot of Swift code with a lot of React Native code, that's easier than mixing large amounts of Swift code and Cordova code, for example. It's very easy to get started, mostly because a lot of people know React and they're very comfortable working with React. There is, this isn't really an apples to apples comparison because Cordova doesn't really do anything in terms of making stuff easy for you to implement in your HTML, right? You don't get a React equivalent where you get a component model or you get, like an event delegation or any of the things that brings. So you would probably want to use something with Cordova in order to build a rich application. As we saw, it's kind of quick and easy, comparatively as easy when you're dealing with iOS as we saw in Cordova. But when you're dealing with React Native and Java, a little bit more complexity. One thing that I think React Native does a little bit better is the whole dealing with callbacks versus promises. Because a large number of the Cordova plugins that are out there in the wild, they're all callback oriented. And you end up having to wrap it in a promise when you consume it anyway, which is just extra work. So here are the takeaways that I want you guys to remember from this whole talk here as we wrap things up. Talking to native code, right? Dealing with opening the black box and taking a peek into it. It is not a completely foreign concept to something you guys do all the time, right? it is just like talking to an API, just like talking to Ajax. And it's a parallel and concurrent thing that's happening at the same time. You have, another thread running. You can use this to great advantage. If you're using plugins, you're going to want to build, if you have to tap into native functionality and you have a new idea that's not built yet, build a Cordova plugin, even if you use React Native. There's a great project that some of the Cordova committers who work at Microsoft have built, and it's called the React Native Cordova Plugin Adapter, because naming things is hard. And this lets you basically consume anything in the Cordova plugin ecosystem into your React Native app. The advantage of building these little bridges as Cordova plugins is that you get to tap into the Cordova developer community, the React Native developer community, the Ionic developer community. Everyone who has Cordova at their core, they're all sharing these, they're all making bug fixes and giving feedback. So more people using stuff is better, especially in open source. And finally, the biggest takeaway here is make sure you get to know this bridge when you're building a hybrid app. Don't treat it just like JavaScript wrapped in something you don't care about. One day you'll have to dig a little deeper. One day you'll have to start touching on native code. And it's much easier if you've kind of familiarized yourself in advance rather than getting that unpleasant, rushed learning curve as your customers yell at you because your app's not working. And that's it. Thank you very much. I hope this was useful for you guys. And I think I might have time for a couple questions here, but thank you.
Okay, since it's not 10, are there any questions? We have some time left.
Yes.
Okay. The micro, so everyone can hear you.
Hey, so you mentioned as one of the advantages of Cordova that there's a mature ecosystem of plugins and everything. So how does that look on the native React side?
So the many of the plugins are non-visual in nature, and it would be something like, give me the battery level on this device. And because it's non-visual, yes, it is Cordova, yes, it is JavaScript talking to some native code, but that's all hidden from your user. And oftentimes, unless you have something really unique and special going on, performance is not going to be a concern here, because it's very infrequent that you would be talking across this bridge, 1 million times a second or something like that. So the important thing is that the bridge be well architected, well tested, and that the native specifics are hidden from the consuming app. Cordova does a great job with that, and it does a great job when you consume Cordova plugins in a React Native project.
Okay, thanks.
Does any of these technologies address Apple Watch or Android Wear?
Yes. So I have not built apps for Android Wear personally. So I'm going to make a big assumption here that it works in a similar way that Apple Watch does. And most of the communication is done through the phone itself. And so at least an Apple Watch, that doesn't have, whenever you have an app on your watch, you have a matching companion app on your phone, right? And so like the app for your phone will bring a watch app along with it. And some of these are just, the phone piece is not important. It's just there to kind of package things. But this is where a Cordova plugin would be fantastic, because you can talk to anything you need to talk to there. And so any of the conventional ways of talking from the host device to the wearable device, that is something that you could wrap in a plugin quite easily. Because essentially all we have here is an escape hatch to get out of JavaScript into native code. And then the whole library of what's possible in native code is available to you.
But would it be possible to write the user interface on the watch as an HTML application?
Ooh, good question. I think it would be possible, but you'd probably have to implement your own UI elements. So React Native comes with abstractions for basic things like fields and date pickers and buttons and stuff like that. But I don't believe it has sort of the primitive elements for wearables, because I'm not sure that it's all that well defined. You know, it's a very different user interface, and I'm not sure that anyone's invested the time in doing that yet. In theory, it should be absolutely possible, because again, you can, if you can do it in native, you can wrap it in a Cordova plugin, and you can definitely do what you're talking about in native.
Okay, thank you.
Okay. Yeah, just to mention, we have as well these AMA sessions, these Ask Me Anything sessions in the backstage track, where each speaker has his own slot. So you can go there and yeah, talk with them individually. So, and I think you will be around as well. So
absolutely.
Staying for today, and yeah, just go to Mike and ask him whatever you want.
And if you guys are interested in seeing the source code for what I just went through, follow me on Twitter, and I will tweet the link to GitHub when I push it up there. All right, thank you guys, and thank you for having me.
Yeah, thank you. As well, and we talked about the speaker president. What else could it be than a Swiss Army knife? Jazoon
Better be Victorinox.
Yeah, you get the speaker and the chocolate.
Oh, thank you so much.
You actually travel with suitcase, so it shouldn't be any problem. Huh?
Yeah,
Okay.
thank you.
Yeah, you're welcome.
Thank you, everyone.